Okay, so let's look at this question from 2015. We have given that consider two relation R1. We have R1 and R2. R1 have attribute A and B, and R2 have attribute A and C, and R1 have tuples that is 1 5 and 3 7. R2 has tuple that is 1 7 4 9. Assume that R is equal R a relation that is ABC. So we have a relation that has the attributes ABC. So R have the attribute ABC is a full natural joint. So this is a full natural joint between R1 and the R2. This is the full natural joint between these two relation. Consider the following tuple from this table, and we will have to see which of the following statement is correct. So let's first find out this full natural joint. So that will be this one. Here it is 1, so we will have this and no other, right? And now whatever the left in both the table, we are going to consider it, right? Because it's a full join. Now we will have 3 7 and C is nothing, so that is going to be null. And now we are also going to consider this. So A is 4, C is 9 and B is nothing, so we are going to get it at null. So we get this 157 3 7 null, 4 null, 9. So 157 3 7 null and 4 null, 9. So we get R contains the EFG but not AB. So this is the correct answer for this question. Yes. Okay, let's look at this question. So this question is from 2014. See what is the optimized version of the relation algebra expression. We have given this relational algebra expression. We will have to look at what is the optimized version of this expression, and we have given that where A1 and A2 are the set of attributes in R with A2 is a superset of A1, or you can say A1 is a subset of A2, and F1 F2 are the Boolean expression based on the attributes in R. Okay, so let's first of all understand this one, that where A1 A2 are the set of attributes in R with A2 is a superset of this A1. So A1 A2, so we have given this the instance of table that is R, and with this we have some attributes that is A1 and A2, and we have also given that this A1 is a subset of A2, or you can say A2 is a superset of this A1. So let me take you an example, that let's take this A1 attribute as maybe last name, and this A2 attribute as a full name, right? So we can have value something like that, Ram Kumar, and here we will have the last name that is Kumar, and maybe with Sita, Kumari Sita. Let me take Kumari Sita, and here we will have Sita, right? So you see that this is your A1, so you can consider this as A1 and this is A2, right? So A1 is a subset of this A2, right? A1 is a subset of this A2. Okay, now let's focus on this expression. So what we are doing is that we are selecting with this some condition F2 and with this some condition F1. So we can compress this and we can write something like that select with the condition F1 and with this condition F2 from this relation R, something like that, right? Now from this selection project the A2, so project this A2, right? Now again you see that if we are projecting this A1, what does it mean? That with this we will have 2, right? So we will project this one, right? So ultimately we are going to project the A1, right? So we can write this as A1. So from this we do not have to write this one, because so that will be, I think that is all. So that is from 1, that with this relation we are project taking, and now we have so the correct answer for this is A. Okay, now let's look at this question. So consider the relation schema given below, where EID of the relation dependent is a foreign key referring to EMPID of the relation employee. Assume that every employee has at least one associated dependent in the dependent relation. So you see that we have these two relation, employee and dependent, and in this dependent, this EID is a foreign key and it is referring to this EMPID of the employee relation, right? We have given this algebraic relational algebraic query, then we will have to find that which of the option is correct, right? So first of all, let's focus on this algebraic query that we have here, the employee table, and this from employee table we are projecting the employee ID, and after projecting it, then what we are doing is we are subtracting this thing, right? So we are taking some projection of employee ID, but before that let's come to this part, right? So here if you see, we have this table employee, and here we have this table dependent, and what we are doing is we are taking the join with some condition, right? So we are taking the join between these two tables with this condition. Now let's focus on this condition. So the condition is that, so we will take only those tuple that will satisfy the condition, right? So that condition is that EMPID is equal to EID, right? And EMP age is less than equals to dependent age, right? So from this employee table and from this dependent table, we will take the Cartesian product with only those tuple that will satisfy this condition, right? So so the first condition is that employee ID should be equals to EID. So EID belongs to this dependent table and this employee ID is there, and this is a foreign key. That means whatever the value we will have here, that those are the only value that is going to be here in this attribute, that is EID, right? And let me do that, right? So the first condition is that this one, that employee ID will be equal to EID. So this employee ID may have two dependent, so we will take these two tuples, but stop right now because we have one more condition, right? And with one more condition, what it is saying, that the employee age should be less than the dependent age. So let's assume that this one has 20, this one has 30, and this one has maybe 10, and this one has maybe 50, right? And let's assume that this one may have 15, and this one have 45, this one have some maybe 30. So now with this condition, we have employee ID is equals to EID, so these are the valid one. But with this AND condition, employee ID should be less than the dependent age. So that means this one if you see the age, that is less. So employee age is less than both of these two age. So that is satisfying the condition. So that means we are going to put this in our with table, right? So what does it mean? So we are selecting those employee who has age of all of his dependent. Okay, let me tell one more time. So what we are, so we are selecting those employee whose age is less than all of his dependent, right? So right, so let me give you an example where we, let's suppose that we have a employee that is 4 with age maybe 15, and here we have 4 with age maybe age with maybe 25, let's take it 25, and here we have 4 with age his dependent whose age is 10, right? So now you see that this 4 and this 4 is there for this condition. Now we will have to check also this condition because and is there, right? So this is 25, so 25 is less than equals to 10. No, so we will be not selecting this one, right? So all the employees whose age is less than all of his or her dependent, right? And with this condition what we are ensuring that we are comparing with only with his or her own dependent, not with the other, right? Now we will project those employee ID. So what we are projecting is all the employees ID whose age is less than all of his or her dependent, right? Now here at the first what we are doing is projecting all the employees, right? So here we will have 1 2 3 4. Now here we will have only let me check with the 2. So 2 is 2 and 2, that is true, and that is, so 1 will be there, 2 will be there, 3 is also going to be there, right? That 4 will be not there, right? So and we are subtracting it, right? What does subtraction means? That here 1 is there, so we are going to cross it out. Here 2 is there, so we are going to cross it out. Here 3 is there, so we are going to cross it out. So at the end we will have this 4. And what does it mean? That all the employee, so at the end what we are getting, the employees whose age is greater than his or her dependent, all the employees whose age is greater than his or her dependent. So the query evaluates to set of employee ID of the employees whose age is greater than that of all of his or her dependent. So this D option is the correct one. Okay, now let's look at this question that is from 2013 year and from CSC. So we have given that suppose relation R1 that has the attribute A and B and R2 that has the attribute C and D are the two relation schema. Let R1 and R be the corresponding relation instances. B is a foreign key that refers to C in R2 if data in R1 and R2 satisfies referential integrity constraint, which of the following is always true. So let's suppose that this R1 is an instance of this table R capital R1, and this R2 is the instance of a table that is of the big R2, right? Now if this R1 has the attribute A and B, right, and this R2 has the attribute that is C and D, right, and C is here the primary key and here A is the primary key, and in question it is given that B is a foreign key, right? So this is a foreign key and it is referencing to this table R2, and in this table R2, that it is referencing to this C, right? And this C is a primary key in this R2 table, right? So, and also it is given that this is satisfying the referential integrity constraint. So what does it mean by referential integrity constraint? So the in the B, what value it will have? Let's suppose that in this R2 table, this C is 1, 2, 3, 4, 5. So this is the primary key that will have this value. And if B is a foreign key and it is referencing to this C, right, then, and it is also, we will have to also take in consideration that it should satisfy the integrity constraint. So B can take the value that is in only C, right? So maybe B could have the value 1, or maybe 2, or maybe 3, or maybe 3, or maybe 4, right? And let's suppose that if I put here 6, is it valid? No, this is not valid. It will not follow the referential integrity constraint because B is referencing C, right? So B will have those value which is in C, right? Nothing more than that, right? Now we have now let's look at this question, that options, that A, project this R1, project this B from R1. So this, let's project this column, and project this R2 from R2 C. Let's project this. Now take this subtraction. What does it mean by taking the subtraction? That you will have to keep only those which is only in B. What does it mean by B minus C? What does it mean? That you keep those that is only in B. But if you see that here, since this is the foreign key and this is referencing to C, every element in B will be from the C, right? So if you subtract it, then this is going to cut it out. This is also, this is also, this is also, this is also, because every element is in C, right? Because B is a foreign key and it is referencing to C, so every element of C will be in the B, right? And even if you take all 1, 2, 3, 4, 5, 6, 5 till 5, then anyhow this subtraction is going to be give you a null set. So this A is the correct option, right? So what could be the possible value of C, right? Even you can, with this possible value of B, you can even take this B as a 1, 2, 3, 4, 5, right? Again you will subtract it, you will find that all these elements are in R2. So that is going to we will not going to consider it in the subtraction, right? And you cannot take 6, that is not in C, right? That will not follow the referential constraint, integrity constraint, right? So the correct answer for this is A. So this question is from CSC 2012. So we have given this relation A, B, C. How many tuples does the relation of the following relational algebra expression contains? Assume that the schema of A union B is same as that of A. So first of all, let's focus on this the expression what we have given, that A union B, and we have taken the join of this table A union B with this condition that A dot id is greater than 40 or C dot id is less than 15, right? And we have taken the join with this table C, right? Okay, so first of all, let's focus on this, that how we can find this A union B, right? We have given this table A, B and C. So A union B will be a set of which of these tuple? So A will have this, will have this tuple, will have this, right? So and we will be not considering this tuple in A union B. Why? Because we have already considered it here, right? A set cannot have duplicate elements, right? So we are not going to consider this. So let's forget about this one, right? Also let's forget about this one, right? Because we have already considered this one, right? So this A union B will have these tuples, right? So now let's assume that this is a new table that we are calling it A union B, and in question it is saying that assume that the schema A union B is same as A. So it, you can consider it as a renaming as A itself. So this is the new A. Now we have find this A union B, right? Now let's focus on this condition, because based on this condition we are going to take the join, right? And what this condition is saying, that A dot id, and this A is not the old one, this A is this A union B. A dot id should be greater than 40. So this is the id attribute, and that should be greater than 40. That means we will be taking this one tuple and this one, right? These two tuple while doing the cross join, right? And with this c dot id is less than 15. So c dot id is less than 15. So look at this C table, and this is the what we want to have. Okay, now we will be taking the join, right? So and this is the or, right? So let's first consider this one, right? So this here, the id A dot id is greater than 40, so that will be there. So Rohit is there and 11. So this, we will take the Cartesian product of this tuple with all the tuple in C. Why we can take it, right? Because for, so let me write, first of all let me write it down. So here we will have 10 and 220, 220 and 02, right? And again we will have 99 and Rohit 11 and 99, 2100 and 01. So these are the two that we have taken, and if you see, this condition is getting satisfied, right? Because here we have or, so this is true. So overall this condition is true, right? Now similarly we can take this one, that is this one, with these two, this one and this one. This condition will get satisfied. So again we will have two more tuples, right? Now what we can do is, we again, you see that this with this, that means you will pick this one, right? And with this you can maybe take which one that you have already not taken, right? Because if you take this tuple with this one, that is this one, we have already taken it, right? Or maybe with this or this one, then we have already taken it. So whatever the tuple is left, because if you will take that, we will be duplicate, and we don't want any duplicate, because table will not have duplicates. Now with this 10, whatever the left, that will be going to be in this table. So with this we will have Okay, so let me first of all, with this we will have this one, and with this we will have this one, and with this we will have this one, right? So again we will get how many tuples? 1 2 3. So we will have total 1 2 3 4 5 6 7 tuples for this question. Okay, so this question is from CSE 2010. The following functional dependencies hold for relation R and S for both the tables, that is B determines A and A determines C. The relation R contains 200 tuples and the relation S contains 100 tuples. What is the maximum number of tuples possible in the natural join? That is R natural join S. So R natural join S, right? And if you see that we have given this functional dependencies and we have the two tables, that is R and S, right? So with the given functional dependencies, can we take the closure set of B, and if we can see that if B is a candidate key or not, because this A cannot be a candidate key, C cannot be a candidate key. So let's take this B, and if see that if for any of the table, if this B is a candidate key or not, so that will be B, and so B determines A, so A will be there, and A determines C, so C will be there and nothing else. So you see that this B is a candidate key in the relation this R, right? Because all the attributes has been determined by this B, right? And now here with this table R that have the attributes A, B, C, and with this table S that have the attribute B, D, E, and it has the total number of tuples, that is 200 tuples, and it has the total number of tuples, that is 100 tuples, right? And this, for this tuple B is a key, right? So how many tuples will be possible with this natural join, right? So here if you see that B is your key, right? So R, so this is subset, this natural join will be a subset of your Cartesian product, right? That means you will select those rows which will satisfy R dot B is equals to S dot B, this condition, right? And from this Cartesian product, now you will project this whatever the attributes A, B, C, D, so total attributes you will project, right? So the main point is this here, this condition, right? So you see that we have 200 tuples in this R, and this S we have 100 tuples. And if you look at this condition where R dot B is equals to S dot B, so since it has only 100 tuples, so this condition can be matched with only 100 tuples, right? So because this has the 100 tuples only, right? And with this B, right, if you try to do the Cartesian product, do the Cartesian product with this condition, then maximum tuple you will get is the 100, right? So the correct answer for this is A. Okay, so this question is from CSE 2008, and question is based on the relational algebra. So what we have to find is, we have given this R and S with the two relation. So here R and S is the two relation, and this PQ is the key in both of the schema. Which of the following queries are equivalent, right? So so let's look at this option 1. Before that, let's take a small instance of the table that we can take. Maybe with the R table we will have PQ and other attributes will be also there, but that would be not beneficial in solving the problem, so we will skip that, because that P or Q the only thing that we need to have in both the table, right? So let's say that this table has maybe 1 2 3 4 5 6, and this S have this 1 2 3 and maybe 4 5 8, right? Now let's look at this option 1. So option 1 is, first what we are doing is we are taking the join with S, taking the R join S. So this R join is S. What does it mean? So this, first of all, this is the subset of the Cartesian product, right? And this basically when we take the Cartesian product on condition based, then that is going to be the join, right? So this, you can think of it as a R with some condition. So that is going to be maybe you will select those row which have R dot P is equal to R dot S dot P and R dot Q is equal to S dot Q, right? So you are going to select those from the R cross S, right? So do the Cartesian product and select those tuple which satisfy this condition, right? So here you can think of that like that, or you can look at that this tuple in R and this tuple is going to satisfy the condition, and this tuple and this tuple, right? So this R join S, this table will be you can say that will be with this tuple 1 4 and 1 4 and 2 5, and with the 2 5, and other attributes will be also there, but we do not have to worry about that. And what then in next step what we are doing is we are taking the projection, we are projecting the P, right? So we are projecting the P from this table. So this is P, right? So we will be projecting this. So this is the complete instance of this query, right? Now if you look at this option 2, in option 2 what we are doing, we are projecting, then we are taking the join, right? So in option 2 we are projecting, so we will project P from R, so P from R, so it will be 1 2 3, and S from P from S, right? So here P from S, P from R, so that will be 1 2 3, right? Then we are taking the join. Now if we'll take the join, that will going to give you 1 2 3, so that will be with the 1 2 3, right? So you see that this one and this one is obviously not a equivalent. So 2 and 3, not 100% sure that these two are not going to be equivalent. Now this 3 and 4 is equivalent. How? You see that, so if you know that R intersection S is nothing but it is R minus S. So how you can visualize this? So if you can use the Venn diagram, so this is R, this is S, right? So you can think of this R minus S is R only, and this you can think as a R total. R1, why I am saying this R only? Because when you will subtract this S from this R, then you will have only R, right? If you look at this in Venn diagram, so this is the R total, this part, right? This is R total, and then when you subtract from S to it, this part, right, then you will have this part only R, right? So this is R only. Now this is R total. So R total is with the complete blue and R only is with the green one. Now think, if you subtract R total, if you subtract R only from this R total, what you are going to get is this middle part, right? So this is nothing but this is R intersection S. So you see that this is R S, we are taking the intersection, and what we are doing here is R minus S and here R. So these two statements are equivalent, that is 100% sure. And now we will have to see that if this 1 or 3 is equivalent or not, right? So what we can do, we can apply this R minus S thing, right? So this is your R table right here, and this is your S table. Now R minus, what does it mean by R minus S? R minus S means R only. So if you want to keep the R only, then you will have to remove, and this is the R total. So this is the R total, you can think of this R total, right? And what will be the R only? The R only will be, you see in S 1 4 is there and 2 5 is there. So R only will be those tuples which are only in R but not in S. So these are in S, so we are not going to keep it in R only. So this will get subtracted and this will get subtracted. So R only will have the tuple 3 6. That is the only tuple that will have the R only. Now what you are doing, from R total you are subtracting the R only. So again from R total you are subtracting this R only, right? So what does it mean? That you will keep those tuples in R that are only in R. So in this R total, if you see that we have 3 tuples, right? 1 4 2 5 and 3 6, and it's R only. Now if you subtract, then this tuple is going to be subtract, right? Because this is in R only. So we will be left with 1 4 2 5, right? And now what we are doing at the end, we are projecting this P, right? So if you project this P, then we will left with 1 2. So you see that this one and this one, we are getting the same instance of the table. So this is also equivalent to 3 and 4. So the correct answer for this is D.